Hey, we are in chapter 4. We have moved into the trigonometry semester, and this is by far my favorite semester of the year for you guys. We are working on a section called angles and radian measure. You've worked in degrees before. Now you're going to be learning about something called radians. I want to give you a recap a couple of the vocabulary terms. I'm not teaching everything. This is just hopefully a quick recap of what we talked about in class today. So with angles, we have this initial side, which is the positive side of the x-axis, the terminal side, which is where the angle ends. Okay, a quadrantal angle is a special angle that the terminal side lies on part of the axis, either the x or the y. Standard position will describe any angle where the initial side is along the positive x-axis. Positive versus negative angles. Okay, so let's look at diagram A and diagram B. A positive angle is one where the terminal side actually came out of the initial side and went up and around to wherever it stopped, but its initial movement was up from the positive x-axis. That's a positive angle. That we call this angle alpha. It's a Greek A, and this is the lowercase version. A negative angle is when your terminal side starts and it moves downward instead of upward. So if it moves downward, we have a negative angle. If it moves upward, we have a positive angle. They've named this angle theta. Theta looks like a 0 with a squiggle or maybe like a Pepsi symbol. Thetas aren't always negative, just throwing that out there. This symbol you see here, this angle they named beta. That's, again, the Greek letter, and that's your capital beta. Looks like RB with the tail being a little extra long. Okay, acute, right, obtuse, straight. The only thing I'm going to say here is a right angle is a quarter rotation around a circle, and a straight angle will be a half of a rotation around a circle. Okay, I'm going to recap your radian measure real quick. Remember, we have this conversion that will help take us from degrees into radians and also from radians into degrees. We could use any of these conversions depending on which one will be appropriate for us based on a problem. The one I've highlighted is the one that we use most often, especially if we're going from degrees to radians or radians to degrees. We'll use these two if we're told angles in terms of rotation. Okay? All right. So when we convert, I want you guys to think in terms of stoichiometry. And what I mean by that, using this basic relationship, pi radians is 180 degrees, we will be converting different angle measures. So the one example I've shown you, this is example 2A from your book, 30 degrees. I just wrote degrees out because I couldn't get the symbol to fit in there correctly. So 30 degrees, if we want to change that to radians, well, then we need 180 degrees below and the pi radians above. And that's going to simplify to just pi over 6. What happens in between there is that this is 30 pi over 180. Okay, so 30 pi over 180. And then you reduce the 30 over 180. If you want to go backwards from radians into degrees, I've chosen to highlight example B. Negative 5 pi over 3 radians, I write it like this. I know it looks odd, but it's just the formatting here. Negative 5 pi over 3. And the radians goes in that numerator box, okay? And then you're thinking about your conversion. 180 degrees is pi radians, but this time we want radians on the bottom so that those units cancel out. Just like up here, the degrees units canceled out, top and bottom. Okay, and that'll leave us with degrees on top in our final answer. The other neat thing that happens here is that the pi's also cancel. And so then you just have negative 5 times 180 divided by 3. Looking here, thinking about a trick that came up, 1 radian does not mean 1 pi. If they want pi in there, you will be shown pi. We see pi a lot with radians, more often than not. but we don't always. So they've thrown this example in, and if you want to see that, you can go in your textbook 4.1, example 3, part C. Okay, also talk to you today about this arc length and central angle formula. Again, your book shows you in example, sorry about that, in objective 3, use radian measure. They give you this formula, okay? You're calculating theta in radians, theta being the central angle. But then in objective 7, find the length of a circular arc. They give you the very same formula. They've just turned it around. I don't memorize 2 formulas. I don't want you to memorize 2 formulas that are exactly the same. Instead, you need to choose one of them to memorize, and the one I memorize is the one that I've starred here, S equals R theta. Okay? In both of these, S represents the arc length. They've shown it to you here in the diagram. The arc length, I compare that to the crust of your pizza. Okay? R is the radius, so from the center out, and theta is the central angle. It just means the angle around the center. And it's always measured in radians. See how I have that highlighted there? When you do this calculation, theta equals S divided by R, your angle is automatically in radian measure. If you use this formula, theta has to be in radians before you multiply by R. Okay? You could also use the same formula to find a radius if you know arc length and theta. Okay, so example 1 goes through using the first version of the formula. Example 8 goes through using the second version of the formula. The one thing I did on example 8, I'm not sure, I'm thinking it's not in your book, they did draw a diagram. But whenever a problem is trying to paint a picture in your mind, I want you to draw that picture. A circle is a radius of 10, and the length of the arc is intercepted by a central angle of 120 degrees. So I've drawn that. We want to find the length of that arc. S equals R theta. Okay, notice the first thing that we had to do was convert degrees for the angle into radians. That's something that's so easy to forget. But if you put in a degree angle, you're going to get a wrong answer. And on the quizzes, it's possible with multiple choice that the wrong answer that you get when you plug in degrees could be a choice. So please, please, please make sure that you convert to radians and then you plug that in. If the directions say simplify, type your answer in terms of pi, that means that it wants this answer, 20 pi over 3 in the answer blank. If it says approximate or round to 2 decimal places, then this is the answer they want. If it says in terms of pi, this is the answer. If it does not say, if it says round, okay, it says round, this is the answer. All right, so that's all for today. I'll do a second video to follow up what we do tomorrow in class. For Math Excel today, if you just do problems 1 through 14, you'll be on track. And then tomorrow I'll talk to you about 15 to 26.